Welcome to the Hydraulic Engineering Lab in room W112, which is used in support of the CE 441 Hydraulic Engineering Design Lecture course. The CE 441 course is required for civil engineering majors under all concentrations. The space dedicated to this lab is 480 square feet with a maximum of 15 students and one graduate teaching assistant. Students access the lab at the door entrance of room W112. There are lab safety information and lab emergency plan and safety signs attached to the door that inform students that eating and drinking are not allowed. Students are required to use the safety glasses as personal protective equipment while operating the open channel flues and water pumps. The safety glasses are provided to the students. Also, there are general information about campus and lab emergency procedures inside the lab on the east wall. The lab also has signs about safety equipment, including a first aid kit, an eye wash station, and a fire extinguisher. The fire extinguisher is due for inspection in May 2022. The Office of Environmental Health and Safety certifies the safety equipment on a regular basis. There is one emergency exit for this lab. The CE 441 lab outcomes are for students to apply the basic principles and concepts of fluid mechanics to calculate hydrostatic forces on flat and curved surfaces, also to apply conservation principles of mass, energy, and momentum, and to use pump characteristic curves and select water pumps under given hydraulic conditions. Understand energy principles in open channel flow and compute water surface profile, and to conduct hydrostatic and hydrodynamic experimentations in a team environment. The AVID student outcomes met by this lab include outcomes 5 and 6. The graduate teaching assistant presents lab concepts and information here using the whiteboard, and students assemble here. This lab is utilized by students working in teams to conduct experiments and analyze and interpret the results to draw conclusions of particular aspects of fluid mechanics and hydraulics theories that are used in designing hydraulic structures. The students are required to submit a lab report for each conducted experiment to illustrate and discuss the procedure, analysis, results, and conclusions drawn from the experiment. Students are encouraged to read the experimental procedure in the lab manual before the lab is conducted. Prior to using the equipment, students are given demonstrations of all equipment and procedure. Data is collected during the experiment time, and students are required to complete analysis and submit a lab report within 1 week after the experiment is conducted. The major lab experiments conducted by students include open channel flow test. In this test, students observe and measure the water depth of a flowing water in a water flume using a tri-stand with hook and point gauge to determine the characteristics of the water flow in open channels under super and subcritical flow conditions and understand the hydraulic jump characteristics. Another experiment done by the students in this lab is the flow over weirs and under sluice gate demonstration test. Students observe and measure the flow depths over different weirs as well as the flow through sluice gate in order to determine the characteristics of the water flow over weirs and through sluice gates in open channels. In order to study the water flow characteristics over rectangular and triangular weirs, students use the hydraulic bench and weirs with a point gauge to monitor the flow depths over weirs under different flow rates. Another test conducted by students in the lab is the impact jet test. In this test, students use the equipment to verify experimentally the linear momentum principle as applied to jets impacting on stationary flat plates, 120 plate, or hemispherical cup. Students also conduct hydrostatic pressure test. In this test, students use the hydrostatic pressure equipment to determine the static thrust exerted by water on submerged surface and enables comparison of measured magnitude and position of this force with simple theory. Students also conduct the Bernoulli's Theorem demonstration test. In this test, students investigate the validity of Bernoulli's theorem of fluids as applied to the flow of water in tapered circular duct. Students also conduct a series and parallel pumps head flow test. In this test, students measure water pressure and discharge in a pipe system with pumps to determine the head flow characteristics of the pipe system with pumps operating individually, in series, and in parallel. Also, students conduct pipe system for energy loss test. In this test, students determine the pressure losses associated with water flow in pipes, piping elements, and shut-off devices or valves. In the CE Laboratories folder in the Google Drive, there is a summary page that describes the features of the space for your reference.